Unit 2 Chemistry, Chapter 19, looking at our final type of analysis of substances in water, and now we're looking at our organic compounds in water. Okay, so this might be where we've got pesticides, herbicides in farming, they run off into the water, we want to find out what concentration we've got in our waterways. Or byproducts of other chemical industries where we're making polymers, for instance. Or sewage, okay? When we go to sewage treatment, we want to check that we don't have any organic waste left over in the water because that's going back into your drinking supply. The process we use is chromatography. Now, chromatography is a separation technique. And there are different types of chromatography, but they've all got four features in common. They've got what's called a stationary phase, something that stays still, a mobile phase, something that moves. We've got a sample that we're going to separate, and we've got a detector. Okay? The basic idea is that the sample will adsorb. That is not a typo. That is supposed to be a D. We're not absorbing, we're adsorbing, sticking, essentially, to the stationary phase. And they're also going to dissolve a little bit in the mobile phase. And the different things you've got in there, some will stick more to the stationary phase, some will dissolve more in the mobile phase, and that will affect how far or how quickly they move. So simplest type of chromatography that you'll have done before is paper chromatography. So your paper is your stationary phase. It's made of cellulose, which has got polar groups on it. Okay? If we try and separate something like pen ink, then those which are very polar are going to attract very strongly to the stationary phase, stick to the paper quite strongly by dipole-dipole attraction or by hydrogen bonds. That means that they're not going to move very far. If we have those that are very non-polar, they're going to dissolve more in our solvent because we'll have chosen a non-polar solvent, and that will mean that they will travel further up. The distance that our solvent travels we call our solvent front. Okay, and so you can see here we've nicely separated out all these colours, which potentially would be from different black inks, for instance. Okay, so our mobile phase moves, and the components will dissolve in it, and again they're going to be attracted to it by dispersion forces, hydrogen bonds, dipole-dipole, and those that are most attracted to it are going to be carried along further. Okay, so as they're moving on, they're adsorbing to the stationary phase and then desorbing, getting away from it, and then adsorbing again and then desorbing. And each time they desorb, they're dissolving in the mobile phase and travelling a little bit further. And each time they adsorb, they're sticking and staying there for a bit. Okay? Now, that's not what really we use for organic molecules, but it's the same basic principle. What we actually use is more complex. It's called HPLC, or High Performance Liquid Chromatography. And we're separating these big organic molecules with normally molar masses which are bigger than 300 grams per mole. So we've got a stationary phase. It's a solid. It's actually normal little beads packed in a column. We've got a liquid mobile phase which is going to move through here. We've got a sample and we've got a detector. Okay? What's going to happen is our liquid with our sample in it is going to go through the stationary phase, which is our waxy porous substance. And as they go through, some of them are going to dissolve very well in that mobile phase and go through. Some of them are going to adsorb a lot to the stationary phase, okay? And those ones are going to take a longer time to get through, okay? They're all going to end up coming through and ending up out here. But those that adsorb very little and dissolve very well will come out quickly. Those that adsorb a lot and dissolve not too well will stay in there for a longer time. Okay? They'll pass through a beam of UV light at the moment, and that will measure how much light is absorbed. Okay? So therefore, we can figure out from the amount of light that's absorbed how much of the substance there is. We're using basically a technique at the end there which is similar to UV vis. So we can do a couple of things with HPLC. The first is we can find out what's present, qualitative analysis. So you put your sample in, it passes through the gel, and we measure how long it takes to come out. Okay? The time taken for each component is going to be specific for that organic molecule, as long as we've done it under the same conditions. So that's our retention time. Okay, so these ones came out quickly. Those ones are the ones that adsorbed the least and dissolved the best. This one came out last, so that meant it adsorbed much more strongly to the stationary phase. And here we can see that we've got 1, 2, 3, 4 big significant peaks, so at least 4 components, possibly 6, because we've got a couple of mini peaks there as well. We might want to concentrate the solution a bit more to find out if they're actually something or if that's just a bit of a system error, which sometimes happens. The other thing we can do is quantitative analysis. So we know the substance we've got in there, but we don't know its concentration. Okay? This would be very similar to AAS and UV-Vis. We know what we're doing, we know what we've got, we just don't know its concentration. So we make our standards. Okay? And we run them through the HPLC and they'll come out with the same retention time because they're the same substance. But what will change is how big this peak is. Okay? So the area under the peak is proportional to the concentration. So then we can plot the area under the peak against the concentration. So this is peak area, this is concentration. For all calibration curves, concentration is always on the x. So we plot all of these, and then we get our unknown, and we can read off the graph to find the concentration of our unknown. Just one point, when we are reading off graphs, let's always make sure we're using a ruler, okay, to do nice straight lines, not just doing a random guesstimate.